All right, so a little overview of identity and access management. Maybe set you off to the right course this week, cover some things you might already know, but maybe introduce you to some things or reintroduce you to some things. This is just a photograph of an old lawyer that worked for Ping, just kind of showing off his own identity. So a bit of a stretch to put it in here, but I enjoy it. So with that, let's get started. So a little bit about me. My clicker's not working. I'm a distinguished engineer at Ping Identity. Sounds like a fancy title, but they ran out of things to call me after about 14 years there, so they gave me that. I tweet occasionally at 2_B_C. Twitter's pretty active here at Identiverse. So if you have something nice to say, it's 2_B_C. If it's something less than nice, it's probably just 1 underscore and then B and then a C. So. And as you've probably seen me already running around with a camera a little bit, I like to take pictures, including this one here of boot camp a couple years ago at Identiverse, what was CIS. I like to put a bunch of pictures into my content here. I kind of go under the excuse that I'm doing it to avoid any sort of copyright infringement violation or anything like that. But the reality is I really just like to do it because I have you here as a captive audience to force to look at my photos. It's a little bit like the old vacation slideshow of the past where you get to sit everybody down and kind of make them look at your stuff. This is going to kill me. Do I need to point this anywhere? Now you've seen everything. Is this user error or? Okay, there we go. So I'm going to talk about IAM, Identity and Access Management. It's nice because it lets you make some little jokes like this t-shirt winner here from CIS a couple years ago. I think, therefore I am. Now, I don't know if this is just really just sort of a silly joke or if there's actually a deep philosophical question here about the true nature of self and how it relates to digital identity. What is IAM? It's about ensuring that the right people have access to the right things at the right time, while also making sure we keep the wrong people out. So a little bit of history. In 1961, the password was invented. Well, technically it wasn't actually invented. Passwords are ancient. But in 61 was the first known usage of a password with a computer system. It was at MIT, right across the river up here. What was called the compatible time sharing system. And each user had an allotment of files and computing time on this system. And that access to that was gated with a username and password. Even back then, IAM was about the right people having access to the right things at the right time. Unfortunately, this system was defeated just a year after its use. And as the story goes, it was with a request to print the password in an offline file. So you could schedule printing requests and pick them up in the morning. And one of the professors that was using the system scheduled a printing request to have the password file printer. Went in covertly the next morning and picked up the list of clear text passwords for the entire system. And then used it, as he said, to continue his larceny of computing time. Now it seems sort of heroic, right? He was an academic researcher and trying to get extra computing time, but gives some idea of sort of the weaknesses inherent in passwords and even our earliest identity-related systems. 16 years later, I was born. That's not actually me, that's my youngest son. We do look similar, except that I'm not nearly as cute as a baby, and I was quite a bit chubbier. We are both sort of unfortunately relegated to being Broncos fans, as you can see from his gear there, and I brought out my Identiverse Bronco socks here just for the occasion. Amazingly, they won the Super Bowl the year this was taken, but he'll never remember that, and with the era of Case Keenum beginning this year, we'll probably long be relegated to sad fandom going forward. I don't really know what happened in those 16 years, but I understand some work was done around protecting passwords, making it harder to actually get access to the password if, in fact, the password file was taken as it was previously on that system, salting and hashing being some of the key ingredients of that. It's really about all I know from that time period. I apologize. 20-some years later, though, the World Wide Web becomes a thing. You may have heard of it. HTTP basic authentication or authorization was sort of the early access model and identity model for the web. In the beginning, you had sort of per application credentials. You'd be prompted with a login box like you see here, enter your username and password, and those would be validated by the local application on every request. Over time, these credentials were centralized into LDAP, and with the credentials being sent and validated on every request, this had, the downside of the credentials flowing on every single request isn't exactly ideal, and having to validate them with a third-party system each time also was relatively inefficient. So we started to see HTML form-based logins, username and password the same, but instead of checking the username and password on every request, that was sent in and validated in exchange for a session cookie, typically stored some opaque value stored in the cookie, referencing server-side state that captured the user's authentication session. It was a better user experience, more efficient, and allowed for things like being able to log out of the system, which HTTP Basic didn't really let you do short of closing your browser. Around this time, I was actually out in the workforce, rather naive, but out in the workforce, and I would write my first single sign-on system. And it had some pretty serious problems. What I was doing was blindly trusting the user ID and a cookie, and a domain-wide cookie to single sign on across different systems. I really hope this isn't still in production. Luckily, though, competent people were also working on the same problem. It was around this time that we started to see a number of web access management products and solutions hit the market. This would give you things like single sign-on, authorization policy, authentication management. Typically, you had a web server agent, but sometimes also these ran as reverse proxies. It would be a domain-wide cookie, but something that was actually secured against tampering by the end user, unlike the one that I did. And you'd typically have a centralized policy server that managed everything. These would be deployed oftentimes in large consumer websites or in enterprises behind a corporate firewall. And you had some cross-domain solutions with these WAMP solutions, something that could go from one cookie domain to another. And they existed, but they were proprietary and not interoperable with other systems not made by the same vendor. But there were cross-domain standardizations underway at the same time. The Liberty Alliance, with their IDE Federation framework, and Oasis developing SAML, we're laying the basis for cross-domain single sign-on. And it was just in time, because it wasn't much later that the rise of SaaS applications, at least in the context that we know them now, really accelerated the need for cross-domain single sign-on. So, I apologize. This is really throwing me off. I'll try to stick with it here. So we are here at Identiverse, which is, of course, Ping Identity is the host sponsor, but we try to be a vendor-neutral conference. So I just want to let you know that if there's any sort of resemblance to actual companies or products here, it's purely by coincidence, and there's no other reason for it at all. So say you go to work one day, and you have a number of applications you use in your day-to-day work. And the first one is you need to go to SalesFolks and log in there. So you pop your browser, navigate to SalesFolks, and you're challenged, and I am challenged, for your username and password there. You enter it. And establish a session there. You go to Workplace 24/7. You prompted for your credentials there. There's a completely different set of credentials. You enter it. You establish your session at that SaaS provider. And of course, you go over to MeetingX next. Same deal. Sign in there. New set of credentials. And how does this make you feel? Of course, that's sort of a rhetorical question. It doesn't make you feel good. It's not fun. Some of you may know Chuck here. The thing is, we really don't want, Jesus, excuse me, I shouldn't say that. This really leads to too many passwords. Obviously, we all know there's too many passwords. They're hard to remember. They're hard to keep track of, but there's also inconsistent policies about how often the passwords need to be rotated, what the characters they can have in them, and so forth. And it leads to a really poor user experience across all these different SaaS applications and vendors. And furthermore, if there's any kind of strong authentication, if any, oftentimes there's not, but if there is, it's applied on a one-off basis per SaaS application. So it's really much more difficult and cumbersome to roll out and exacerbates all the same problems. Not only do you have a proliferation of passwords, but you have a proliferation of second factor, if in fact the SaaS even supports that. So SAML, developed in Oasis, was one of the early solutions to this, and the flow looks similar, at least from the perspective of accesses in the applications, but goes a little bit different, and we'll go through that. So you come in, you go to sales folks. Sales folks sees that you're not authenticated, and it sends you back, redirects you through your browser with a SAML authentication request that flows through your browser and delivers you to an authentication or a SSO system within your organization. I show this here as sort of a generic SSO server. It might be on-premise within your org behind your firewall. It might be an IDaaS type service, or it might be your own system running in a public cloud. It really doesn't matter, but conceptually it's the same. You get redirected to some system that is sort of a global authority for your identity as known to and registered with these SaaS applications. So the SAML authn request is delivered to the SSO server. You're prompted to log in here, Pong identity. After you enter your username and password, perhaps you actually have a second factor, which is nice because it's utilized once within the context of your global authentication authority and not on a per SaaS basis. Once you're successfully authenticated here, a session cookie is delivered to your browser, establishing a secure logged on session with your SSO server, and in turn with that, a SAML assertion is sent through your browser and delivered to the SaaS application. So sales folks can consume that and establish a session for you there. So you're logged in there using your corporate or your IDP credentials. The next SaaS you navigate to, you want to go to Workplace 24/7 to do your thing. The same flow occurs. The authn request is sent back through your browser and delivered to the SSO server, but that comes with a session cookie previously established, so you get true single sign-on here. You're not prompted to log in again, but a SAML assertion is delivered on your behalf through your browser to Workplace 24/7, and you're logged in there. And obviously this flow can, session cookies established, can repeat itself to any number of applications that you access throughout the day, and you get true single sign-on. So what is SAML? It's an XML standard for exchanging security and identity information. The flow looks a little bit like what I showed you before, but I want to show a little bit of XML here just to try to establish some level of technical credibility. It doesn't really matter what's on here, but I know you can't see it, it's too small, but I'll go through sort of the general big ideas of what's in this content because those concepts are somewhat relevant. Within this is some information about who's it from, who issued this. So in the case of the previous example, this is Pong Identity that actually issued this assertion. There's a signature over this whole thing. As you saw, these flow through the browser. So there's the opportunity for the end user to meddle with it, but with the signature, it ensures the integrity of it so that if it's changed in transit, the signature won't validate. There's who it's about, the subject of the assertion, who the actual end user is that you're logging on. In this case, it's me. There's some constraints on its use. And some more constraints, including where it can be delivered to, how long it's valid for. I'll just jump around. There's who it's to. So this keeps it from being redirected from the actual intended recipient. It's issued for a particular SaaS application and can't be used elsewhere. And then there's some information about how the authentication was actually done. And then there's also a bunch of additional optional user information, just user attribute information that the IDP deems appropriate or that's necessary between the two parties in order to establish the logged in context. So in the early days of single sign-on and federated login, I think a lot of people envisioned that the relying party, in the case we showed before, the SaaS application, wouldn't need to actually own identities, have a data store of the identities on their side. It would just pick up the information from the sign-on and carry them through. But in practice, that hasn't happened. The reliant party system either wants to maintain the user data for sales and marketing purposes, for authorization and access control within their own system, possibly for billing type situations. It's really, in the vast majority of cases, the reliant party application, be it a consumer or an enterprise type SaaS, wants to and needs to have identity records within their organization. And so there are oftentimes APIs for creating and updating that kind of data that are one-off and bespoke to the particular SaaS. But there is a standard SCIM, System for Cross-Domain Identity Management, which was sort of a backronym to fit with what it was once originally called Simple Cloud Identity Management. When it moved into the IETF, they, I guess, wanted to give it a more respectable name. I don't know, simple and cloud, I guess, weren't okay. But basically, this offers an open and standardized API for automating the management of users and groups across boundaries of the domain. So it gives you basically CRUD, read, write, update, and search type operations for maintaining the set of users between the local corporate IT environment and the various SaaS applications. So while the SAML sort of communicates the user's authentication information flowing through in the actual browser session, this SCIM gives you a standardized way to maintain users, the groups that they're in, and the attribute information about them across these corporate boundaries by sending these messages to update and manage the users. Hey. So SAML is still around, still gets used. I use it every day, but it's considered kind of old school. Back here, what is it, in 2012, Craig Burton declared at the Cloud Identity Summit that SAML is dead. I don't think he really killed it off, but it certainly was the beginning of an era of its usage slowly sort of being phased out in favor of what's sometimes been called the O stack or OAuth and OpenID Connect. This is a recent tweet I stole from Pam where giving some numbers around Azure, I don't know the exact context of all this, but basically it's saying that the overwhelming vast majority of transactions that they see now in Azure are OAuth or OpenID Connect, as opposed to a much smaller percentage being SAML. So it gives you an idea of sort of where the direction and usage and sort of favored identity protocols are going now. SAML's not gone, but it's certainly diminished in the amount of usage, and particularly more so in new deployments. So I want to look a little bit at some of the drivers around this. In addition to when you had single sign-on, you had sort of web access to those applications, SaaS-type applications, but many of them also had API access available to them as well. If you take away the password from the SaaS, which you do when you're in single sign-on, you're only using your IDP credentials. You don't actually have credentials established at the SaaS. There's no way then to directly access an API with HTTP Basic or some other sort of direct authentication. So that was one of the main drivers behind OAuth, and a potentially fictional large-scale SaaS company that may or may not have built this building later on. I remember even years ago hearing that they had were starting to have significantly more traffic against their APIs than they were against their web properties. So some of the other drivers, OAuth gets used both in corporate and consumer cases, but a while back, around the same time, 2010-ish, you were seeing a lot of sites literally asking you for your password and username in order to access your stuff on another site. Here's a relatively benign example. We have a large sports website offering to go and look in my contacts in order to invite my friends to play fantasy football with me. But in order to do this, I have to give them basically the keys to my digital identity online, give them my redacted username and password. And while I probably trust what they're going to do, it's establishing a terrible pattern, because they may only go through and grab a few of my contacts and spam a few of my friends. But by providing them this password, they could potentially do anything, include changing my password, locking me out of my own account, destroying all of my information, or stealing all of my information. There's really no telling. It teaches users to be indiscriminate with their password, to share their password in ways that they probably shouldn't. It doesn't give the main provider site any way to differentiate the access between me actually accessing that information and some third party accessing it on my behalf. And it locks out that system from being able, if they want to continue allowing this kind of access, they can't implement any stronger forms of authentication without breaking the access provided sort of indiscriminately through these other methods. So OAuth was brought in basically to help alleviate this problem and give a more standardized method of accessing resources on behalf of a user at another site, but in a limited way. Around the same time, too, we saw a huge shift in the development of SOAP-based services to REST and JSON-based services. And while it had its critics, but there was the whole WS star stack for protecting and securing web services, there really wasn't anything comparable for REST-based standards and basic HTTP and JSON type requests and responses. And that's where OAuth stepped in to sort of fill the void. So OAuth 2, largely in a nutshell, is pretty basic, at least conceptually. You have a resource owner, some user. In the previous example around ESPN, Google, I'm gonna just use the real names because I'm a little lost. You have a resource owner. That would be me trying to do my thing. You have a client, which in that example would have been ESPN, that's trying to access some things on my behalf at a resource server. The resource server is the API or set of resources that have data relative to me, to the resource owner. And then you have the authorization server, which is the system that both authenticates the resource owner and grants access to the client to access the resources on their behalf. So it goes basically by the client requesting a token from the authorization server and then using that access token to access resources at the resource server. And for the most part, this happens through a web redirect flow, and you're prompted with something like the screen on the right when you go through there. So the client is redirected to the authorization server, the user logs in, and then grants access to the client to, explicitly is asked and gives access to the client to access those resources on the user's behalf. OpenID Connect is built on top of OAuth 2. It builds itself as a simple identity layer on top of the OAuth 2 protocol. OAuth was all about delegating access and access to resources. There's no actual defined identity information that goes through the flow, although identity is often involved. It's not actually required or built into the layers of OAuth. OpenID Connect provides that identity layer on top of it, basically to do SSO using an OAuth type flow. It adds an awful lot to OAuth. I won't go into all of it here, but the main thing that it adds is a JSON web token based ID token that flows from the authorization server, to the client and represents the end user's login information. So it logs the user on, similar to how it's done in SAML, from the authorization server to the client. It's not really as simple as it would like everyone to think it is, or at least as it claims in its abstract. But it does some interesting things in terms of how the complexity burden is shifted. SAML was very, very complicated both on the identity provider and the relying party. In OpenID Connect, the large majority of the complexity burden is shifted onto the identity provider, where arguably it's most appropriate. The identity provider, there's likely going to be less of those deployed out in the wild, and they're likely more likely to have the resources to build it correctly on their own or use a proper service to do that functionality, while there's more consuming services, and the simpler side of the protocol then is on the consumer, where there's less resources to build, there's more in terms of just sheer numbers of people that are on the relying party and the consuming side of things. And there's probably another bullet here. And OpenID Connect has seen a lot of adoption both in consumer and employee enterprise type use cases. So we mentioned JSON Web Token as being sort of the identity token underpinning in OpenID Connect. Just give a quick overview of what that looks like. Here's a JOT. It's meant to be pronounced JOT. I'm still not exactly sure why, and I still get them mixed up. I use them interchangeably, but JWT or JOT. And the main type you see is signed, and it has three parts here, three encoded parts that make up this token. The first is the header, which just has some meta information about it, the algorithm that was used to sign, and maybe a pointer to the key, or a hint about which key to use to verify it. You have the signature itself, which is just base64 URL encoded binary data of the signature. And then you have the payload, which is sort of the meat of the thing, which has the what are called claims, the identity information, Very similar to the SAML token, you have the issuer, who issued this thing, who it's from. You have an expiration date, some constraints on its usage, the audience, who it's intended for, who's allowed to consume it. You have the subject information and potentially information about how the user authenticated, as well as many other things, but these are sort of the common ones that you would see there. And all that is just a JSON payload, typically just flat username and flat name value pairs, sometimes more complicated, but usually just the flat name value pairs, base64 URL encoded and then placed inside the body of this JWT. And just by way of comparison, maybe, this JOT and this bit of SAML that may or may not come are not exactly the same, but at a conceptual level, they can convey basically the same information and same security considerations with them. And you can see the very vast size difference between the two. And furthermore, the JOT is already encoded with characters that make it safe for usage on the web, whereas the SAML assertion is raw XML. And for most use cases to be transferred in the web, it needs an additional round of encoding, either URL encoding or base64 encoding, which would make it even larger. So size actually really is important for these tokens. There's a lot more use cases you can use it in. But there's also a lot of value in how it gets used and how the actual implementations work. In general, particularly when you're doing things with security, simpler is better. And JOT is significantly simpler than XML and XML signatures, which are used in SAML. JOT uses a web-safe encoding, and there's no canonicalization step. If anybody's actually dealt with canonicalization in XML, it's really, really, really difficult to get right, both from an interoperability perspective and also from a security perspective. And JOT and the underlying Jose specifications don't try to do canonicalization simpler. They don't try to make it better. They just got rid of it entirely and did something completely different. So canonicalization just isn't a concern. And as a result, there's improved interoperability and security. Now, I think this has mostly been true. There are some critics of JOT out there, and it's had a few high-profile problems, mostly around implementation, and some would argue that the standards were written in such a way that allowed those implementation problems to occur. But overall, at least when compared to SAML and XML digital signatures, it has been wildly more secure, easier to use, and more interoperable. And that's largely because it eliminates entire classes of attacks, at least versus XML signatures. I won't go through all of these here. I don't even remember all of them because some of them date back 5 or 10 years. But the last one here, bypass from inconsistent treatment of XML comments and canonicalized XML and what the XML APIs had. This actually came out, Duo Security released and found this just late last year. So even as recently as last year, in a technology that's been deployed on the web for over a decade, we're finding and being exposed to new attacks on XML signatures and canonicalization. It's very, very hard to get right. Many of you probably use a phone. I do too. There's a lot of them in use. People are using more and more of them. I think it's cut off here. Oh, yeah, I'm sorry. It says analysts predict there'll be 5.42 zillion mobile devices in 2021. And I go on to say that analyst might have been me. But they are getting used a lot, and signing into mobile applications is a real need and something that's more difficult to do because of the small keypads and so forth. And OAuth 2 has actually emerged as a best practice to be used for sign-on and single sign-on with native mobile applications. So much so that there's a IETF RFC that's a best practice guidance for using OAuth 2 in conjunction to sign on to mobile applications. And the word sign-on is a little bit maybe misleading because really what you're doing is using the OAuth 2 protocol to authorize the application on your mobile device to act as the client on your behalf to access APIs and access data on your behalf with the backend. So it works a little bit like this. On your phone, the phone's the bottom part. The top part here is sort of the home application or service, which has its APIs as well as an OAuth authorization endpoint. That's where you go to interact as a user, and a token endpoint. That's where you go to exchange tokens. So the first thing that happens is the native application, assuming you're not authorized, don't have tokens to access the APIs, it pops up a system browser And however that's appropriate for the OS, it might be some of the newer in-app tab type functionality, but it could fall back to a completely distinct system browser. It requests authorization, sends you the authorization endpoint in your browser, along with a PXE challenge, which helps secure the native application on the callback. Within that browser, the user authenticates and approves access, very similar screen to what we saw before with the OAuth consent screen. Once that's done, a callback is issued via redirect to a custom scheme URI, and that custom scheme then is registered in the OS for the application to pick up as a callback handler. So the application picks that up. The callback URI has on it a authorization code, so the native application picks up the redirect, pulls off the authorization code, and then calls into the token endpoint at the authorization server via OAuth here to exchange that code for actual access tokens that it can use, and probably a refresh token as well that it can use to access the API and get more tokens in the future. And then it accesses these protected APIs on behalf of the end user to do whatever it is that the application does. This is a nice experience, but one of the special things that it does, it enables both federated and multi-factor single sign-on across these applications. So by deferring to the system browser, you get the benefits of single sign-on. If there's a session already established in the browser and another application needs to flow through the same thing, same flow, it'll get used to the established session already. And because you're in a browser, you can also it doesn't help when I point on it. You can also authenticate here using enterprise or enterprise or social identity provider doing SSO back to your home application or with a social identity provider and multi-factor authentication. Anything that you can do in normal web authentication, you can do here in order to facilitate API access. And this lets you leverage existing and future investment in web-based authentication, where most of us are already putting and investing our effort into improving the authentication experience. Using OAuth this way defers that experience and gets you the same benefits for your native application sign-on. We also have FIDO, speaking of authentication, which is a standard to basically standardize online authentication using a public key cryptography system. In some ways, I like to think about it as PKI without the I. There's no infrastructure, there's no public key infrastructure set up to make FIDO work. It's all just raw public keys. There's two variants of the original FIDO. There's UAF, Universal Authentication Factor, and U2F, Universal Second Factor. U2F is the one that really got more adoption. FIDO, by the way, stands for Fast Identity Online, but gives me a chance to put a dog picture in there. And what U2F does is it gives a strong cryptographic, public key-based second factor option for end user security. You have a U2F device, which could be any number of things, including a USB key, NFC device, Bluetooth, low energy, or even something on board your machine or your mobile device. And then the registration of a client-generated site-specific public key. So for every site that you authenticate with using the FIDO protocol, your U2F device registers a new, unique public key with that system. And then to authenticate later on, you authenticate by using that public key, the private portion of it, to sign a challenge issued by the site. FIDO's found a new home. In the course of working on FIDO 2, it moved the main bulk of the work from the FIDO Alliance to the Web Authentication Working Group within the W3C. And the mission's much the same, although broadened and expanded in interoperability. What it does is define a client-side API in JavaScript, providing strong authentication functionality to web applications. It achieved candidate recommendation status, which is a big deal in the W3C, in March of 2018. And support for it was demonstrated in Chrome, Firefox, and Edge earlier this year at the RSA conference. The client to authenticator protocol, CTAP, is still in the FIDO Alliance, so FIDO Alliance is still active, but that defines sort of how the actual authenticator portion, the key, communicates with the client, the web browser. So they're working together in the standard, but The main functionality of FIDO is moved into WebAuthn and the W3C, and I think it's created a little bit of confusion about where things are, but it's not uncommon to see sort of an industry consortium protocol, once it gains some acceptance and popularity, to move into a more rigorous standard organization. It might create a little bit of hiccups along the way, but over time I think it's better for interoperability and deployment, and probably will ultimately lead to more universal deployments or access to it. So we go through a content review process here at Identiverse, and Andy Hendel, our conference chair, looked at these slides, and he asked that I maybe, he said it would be useful if maybe I could include a reference to XACML, UMA, and maybe SIBA. And apparently I don't do very well with constructive feedback, so I thought I'd get back at him by including a picture of him in here and throwing it up there. But I will cover the things he asked me to cover, although I don't know them very well. XACML stands for Extensible Access Control Markup Language. Basically, it defines a policy language and an access control decision request and response processing model for authorization queries. So it's an XML-based language to sort of define policy, as well as an XML-based request response language to query a policy decision point to make policy decisions, access control decisions on the fly. UMA is user-managed access. I copied, I think, this verbatim, but it's OAuth-based protocol designed to give a web user a unified control point for authorizing who and what can get access to their online personal data, content, and services, regardless of where those things live on the web. It's a very rich authorization protocol that allows for sort of a unified point of access. And then there's SIBA, which is interesting because it's actually called, SIBA is short for Client-Initiated Back-Channel Authentication, but it got included here in the authorization. It was asked to be included in the authorization thing. And it really is, I think, an authorization flow more than anything, rather than authentication. What it is a direct communication from some client, an OAuth-like client, to an authorization server or OpenID provider with an asynchronous result delivery where user consent is collected and given out of band on a user's device. So think of a third-party like payment system initiating the flow to make a payment on your behalf, but you don't interact directly with it. You only approve the payment or approve the flow based on your phone, which is the third-party authorization device. It's an interesting flow. It has some problems around sort of potential security and privacy implications about discovery of the user, how to actually kick off the flow without them being involved. But it's recently gotten some additional interest around some of the FAPI working group and open banking working groups that might see it get some more stress and pressure, and maybe it work through some of the deployment issues that it might potentially have. So I got a little out of order here, I think, but I wanted to talk a little bit about the phone. Basically, your phone is becoming a nearly ubiquitous something you have, something that can facilitate a very easy, usable second-factor authentication. But at the same time, standards like FIDO are making it easier to have fewer hard tokens as a second factor as well. One of the original problems with hard token type second factor things is that you have to have a different one for every application, every deployment of it. With a standardized one, you might potentially be in the position where you could have a single token managing access to everything you have. I think at the same time, there's still tension between, are we going to carry tokens? Are we going to have the authentication built into our phone? Are we going to use the token as a second factor to our phone? Time will tell, but the upside of all this, I think, is that there's second factor, stronger authentication methods that are also becoming much, much more convenient to use and carry with us. And at the same time, maybe, we're seeing biometrics deployed in a way most of the time that I think actually makes sense and doesn't bring about the potential problems you have with privacy implications of biometrics, and the fact that you can't change your biometric data. So if it's taken, that can be a real problem if a site is using it for remote authentication. But a more responsible, and I think something the industry seems to be coming to accept, is that biometrics can be used more safely simply as a local device unlocking in order to unlock a key that itself then is used in remote authentication. So the biometrics data doesn't leave your device. It's sort of a convenient security and authentication factor to a local device in order to unlock a strong asymmetric key pair that in turn is used for remote authentication via a protocol like FIDO. And something that's kind of near and dear to my heart, and I've got a session on this tomorrow if anybody's interested in hearing some of the deeper details, is an emerging protocol out of the IATF called Tolen Binding. Two pictures up here. One is of the city of Dallas, where the IATF meeting was held, where the Tolen Binding working group was first introduced and first started working on this. I think it was a couple of years ago. And then up in the right there is the actual working room where it happened. One is a little bit more glamorous, the other. And as you see a bunch of nerds sitting in a conference room, the actual work isn't particularly glamorous. But what Tolen Binding does is it enables a long-lived binding to a browser or other client-generated public-private key pair, which in turn is then used to sign this TLS exported keying material and then sent as an HTTP header. And that doesn't really do anything on its own, but ultimately what it does is, through the combination of TLS and HTTPS and this additional header that's sent, it proves possession by the browser of a specific public-private key pair. And in turn, applications can use that information to bind cookies or other tokens that have been issued to that key, such that they can't be used by any other system without also proving possession of the corresponding public-private key. It makes exfiltration, reuse, and replay of the security tokens we have, like cookies, SSO tokens, and OAuth tokens, much, much more difficult. This stuff's still in the early stages, but I'm excited about it. I think it's really promising. So Andy had some other feedback, and apparently I give it right back to him. He wanted a little bit of a summary type thing here. So this is a token attempt, pun fully intended, to illustrate where the various standards all fit together. So if you're looking to do single sign-on, you've got OpenID Connect and SAML. For API authorization, you've got OAuth. For other types of authorization, you've got XACML and UMA. Strong authentication is found, at least in the standards world, although there's a lot of vendor solutions as well, in FIDO and WebAuthn. User provisioning, again, the standard version of it is in SCIM, although you have proprietary provisioning all over the place as well. And for proof of possession, stronger key-bound tokens, you have Tolen Binding. I didn't include it here, but there's also some work going on to allow for mutual TLS-based binding of OAuth tokens as well that gives a lot of the same benefits with a little bit different deployment model and something that focuses on existing technology instead of the new technology that's not here yet. And so you might be wondering, are we done yet? We're almost there, but got to do a little summary, maybe. And then it skips ahead. I appreciate you all bearing with me through this. So IAM is about seamlessly enabling the right people to have access to the right resources at the right time. Going forward, I think we'll see more and more federated single sign-on to SaaS and organizational applications deployed wherever. That could be, on premises, in public-private type cloud scenarios. And then also in the social world, you're going to see, or in the consumer world, you're going to see a lot more social login to consumer type applications. Either way, you're reducing the actual number of credentials you have to have, sort of consolidating your authentication to one or more likely a smaller number of providers, and federating those credentials out to all the applications that get used. Maybe we'll have a clicker that we're going to see stronger user authentication, both I think in vendor supplied solutions and solutions like FIDO, where the authentication itself will be stronger, but you'll see less frequent direct user involvement in it. So while the authentication gets stronger, the actual user experience will get better because you're not interacting directly in the authentication event as much. And we'll see stronger sessions and SSO tokens bound to keys on the device itself, which again allows for these sessions to live longer because they could live longer anyway, but they're still strong because they're bound to the device and they don't have the same potential for abuse that they might previously have had. And with that, I'm done. Thank you very much for putting up with my stumbling through the timing here. I appreciate everyone coming.
Okay, we have a little time for questions, and if you could wait for me to get the mic to you, we are recording this for posterity. So, does anyone in the room have questions? Can we get the house lights up as well? No, that was all completely clear. Our next speaker has a question. You guys get to meet Mike Schwartz.
Brian, could you tell me what canonicalization is for XML?
In what level
Easy
of detail? Yes. So the idea is, in a lot of formats like XML, you can have the same data, the same meaning behind the data represented in multiple forms. So in XML, white space isn't important to the meaning of the content. There can be a lot of white space or a little white space. The namespaces can be encoded in different ways. Basically, the same information can be represented in different ways in XML, but be semantically equivalent. And canonicalization is, in theory anyway, a transformation that normalizes the XML into a format that takes out the ambiguity of multiple encodings and ensures that the same core meaning of the document is represented the same way. So when you go to sign something, it's canonicalized before it's signed to try to take out the ambiguity of different encodings, different white space, and the various differences that can come up in XML.
Will your presentation be downloadable?
I don't know. I believe that we make everything available, both slides and recordings of the presentation sometime afterwards, but I'm not sure the details. I can put this up on SlideShare or something though, and I'll tweet out a link to it to make sure it is available. I'd like to relive the pain.
The growth of the biometrics for multi-factor authentication. We're starting to see a lot of authentication come through contextual via risk-based authentication or adaptive. Do you have any comments on how that kind of fits into the scenario you discussed today?
I think, I don't know exactly. I think it's going to be one of many factors that start to be involved in the decision about both whether access is granted and whether authentication needs to occur. So I kind of skipped over it at a high level, but the idea that we'll have stronger authentication, but with less frequent user interaction, I think plays right into the idea that adaptive and sort of user behavioral analysis will help that occur, and the signals that come from that will help inform decisions about how often and when and at what point you need to re-authenticate a user, really make sure it's them, versus just letting them flow through on an existing session. Any more detail than that? No, I can't say.
All right, we have time for one more.
So in one of the slides you mentioned for single sign-on we can use OIDC, right? So is that enough to use OIDC for single sign-on without using the session token?
It was the question,
The question is that for single sign-on, don't we need to use the session token? Is that enough to have the OIDC JWT token?
So typically you see OpenID Connect and SAML used for the transfer of the login information from one site to another, but the actual session is established and maintained at the relying party, whoever receives that token, and that typically involves reissuing their own session token in their own format. I know there have been some deployments and some people that have tried or are interested in taking the ID token itself and using that as the session representation locally, but it doesn't work very well. It's usually, you have to work around some of the implied security within the JOT itself, and typically those are relatively short-lived, on the order of a few minutes, where you might want your session to be multiple minutes, hours even. And you probably want to extend and do things with your session that aren't enabled by just using that token itself. So I would say best practice is to consume the SSO and reestablish the session locally.
Which is a great segue to our next talk. We're going to take a 10-minute break here, and then we will come back and talk about OpenID Connect best practices with Mike Schwartz. Please, big round of applause for Brian Campbell.
Thank you.